So the last transformation we're going to be looking at is the rotation. All right. So again, transformations, a transformation is an operation that maps an original geometric figure called the pre-image, that's what you start with, onto a new figure that we call the image. Okay, so you're starting with a figure and you're changing it in some way. We've looked at the dilation, the translation, which slid it, and then the last one we looked at was the reflection, which kind of flipped it from one side to the other. So this next one is called a rotation, and it's exactly what it sounds like. You're going to just sort of rotate it in a circular motion. It's a transformation in which a figure is rotated or turned about a fixed point, and that point is called the center of rotation. Each point of the original and its image are the same distance from the center of the rotation. All right, so of the four transformations, the rotation probably is the maybe the most difficult, or at least the more, if there's one that's going to be confusing, it may be the most confusing, but you're going to get some rules on the next page that are going to make this a lot simpler. So if you stick with the rules, then this should be pretty just self-directed. Okay, so example 1 says triangle LMN with vertices L54, M57, and N87 represent a desk in Jackson's bedroom. He wants to rotate the desk counterclockwise 180 degrees about vertex L. Graph the figure and its image. Determine the coordinates of the vertices for triangle L prime, M prime, N prime. All right, so one thing we need to understand perhaps is this word counterclockwise. So if you think of a clock, right, if we're thinking of a clock, and if the clock, if we say something's moving clockwise, then it means it's moving the same direction the hands of a clock move. So it's going this direction, all right? If it's going this, so this would be clockwise. And then if we think of counterclockwise, all right, if this is our clock, then counterclockwise, the hands of the clock would be going the opposite of what they normally do. So this would be considered counterclockwise. We also need to be aware of some of these degrees. So in a circle, if we think of something moving 0 degrees, it hasn't moved at all. If it's moved 90 degrees, then if we think of this as being 0, starting at 0, like at 12 o'clock on a circle, then 90 degrees, if the hands of the clock move 90 degrees, then this is 90 degrees right here, right? Because it makes like a right angle, right? The hands moved from here to here, so that makes a right angle, 90 degrees. If it moves 180 degrees, it's got to keep moving, right, this direction. So 180 degrees is when it would be straight down right here. So this would be 180 degrees here. If it continues to move, right, clockwise, and when it gets over here, this is considered another 90 degrees. So if I add the two of those together, then this right here is called 270 degrees. And if you kept going, right, if you added another 90 degrees here, then you'd be back at 0, or you would say you did a whole 360. So think about it. You may use this in skateboard terms and stuff, or maybe you've heard them in other places, but if you do a 180, you turn around. If you do a 360, you've turned completely around, okay? Same type of thing in rotations. Counterclockwise, if they're asking you to move counterclockwise, then if this is 0, 90 degrees counterclockwise would be over here, right? This would be the 90 degree, okay? And then 180 would still be down here, but counterclockwise 270 is gonna be on this side, okay? So pay attention to whether or not you're doing clockwise or counterclockwise. I would show you though, right, that 90 degrees in clockwise is the same as 270 degrees counterclockwise. 180, they're both the same. And then again, if clockwise 270 degrees is the same as going counterclockwise 90 degrees. So that's going to be helpful later. All right, so example 1 says, well, we've already read it, so let's look at step 1. Graph triangle LMN. So I'm going to go ahead and start with the coordinates LMN. So L is 5, 4. So 1, 2, 3, 4, 5, and then up to 4. 1, 2, 3, 4. So this would be L. And then M is 5, 7. So 1, 2, 3, 4, 5, and then 7. 1, 2, 3, 4, 5, 6, 7. would be M. And then 8, 7, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. This would be N. Okay, so I've got my first figure. This is my pre-image triangle LMN. Then it says, all right, use a protractor to measure 180 degrees with M as one point of the line and L as the vertex. Mark off a point the same length of, that just means line ML. Label this point as M prime. Okay, so we are rotating 180 degrees around the vertex L. So we're moving this 180 degrees. So we could shift it around 180 degrees. Now, since we're rotating around L, right, L's not going to change. It's just going to kind of slide around here. So it's really M and M that we have to figure out. All right, so let me grab my protractor. And it says I'm looking at, L is kind of stationary, right? So this is M, if you can see, right? I've got LM right here. And now if I move it, if I keep L where it's supposed to be here, right? And I move the protractor 180 degrees. So this, if this is 0, then 180 degrees is down here, right? So I have to move it all the way around. Okay, it's down here. So then where would M be now? This moves around L. So this was 1, 2, 3 from L, and now it's down here. 1, 2, 3, it's down here. This would be M prime. Okay, same thing with Ln. So I'm starting, right? I'm starting Ln as my, and L's not going to move. It's just going to stay the same. So if this is my line segment and I need to move it 180 degrees, then it's got to flip all the way around until I get here, okay? Now it didn't change. So N's got to be the same distance from L. So it's like, if I look at these diagonals right here, it's 1, 2, 3. So if I do the same thing on this side, 1, 2, 3, that gives me N right here, or N prime. All right, so I can see L doesn't change. It's L or it's L prime. And then my new figure looks like this. So this has rotated around this. All right, so if I go ahead and find the coordinates now of this point, L hasn't changed, so this is just 5, 4. M, okay, is now M prime, so 1, 2, 3, 4, 5. It's 5, but it's going to be up 1. And then N prime is 1, 2. Is that 2? And then up 1, 1, 1. Okay? All right, so let's look at another example. It says rectangle KLMN with vertices K, -7, 4, L, that's -7, 1, M, -2, 1, and N, -2, 4 represents the bed in Jackson's room. Graph the figure and its image after a clockwise rotation of 90 degrees. About vertex M, determine the coordinates of the vertices for rectangle K prime, L prime, M prime, N prime. All right, so I'm going to start by just graphing the original figure. So K is -7, 4. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. -7, 1. Oh, that's K. -7, 1 would be right here. That would be L. -2, 1, 1, 2 would be M. And N is -2, 4. 1, 2, 3, 4. This is N. All right, so this is my pre-image. It's a rectangle. Okay, and I'm shifting about the vertex M. So M is going to be stationary, and then I'm going to rotate it 90 degrees. 90 degrees. All right, so if this right now is KM, if I'm starting here, if M is my, if I look at this line right here, M is K, or KM right here, right? And then if this is like 0 and I want to move it 90 degrees, so from here, I need to move it at 90 degrees, like right there. And then where did K go? That's what I need to know. So I'm going to start with actually L, because that's a little easier to figure out. So here's L. Okay, if M stays where it's at and I rotate 90 degrees, then L is going to be straight up like this too. All right, so this is 1, 2, 3, 4, 5, right? 1, 2, 3, 4, 5. Oh, sorry. 1, 2, 3, 4, 5. So from M, it should be 5 spaces away. So 1, 2, 3, 4, 5. This would be L prime. Okay, then if I do N, Mn, all right, I can see M, if M stays the same and N is right here and I want to move N 90 degrees, so I've got to go from straight up to this way, right? I'm going to move it down here. All right, so right now N is 1, 2, 3 from N, so it would have to be 1, 2, 3 from N this direction. So this would be N prime. So what M doesn't change because it's the center, right, of rotation. So I can see that my rectangle K's got to be right here, right? So I'm just going to go ahead and make it K prime right there, right? And if I draw my new figure, okay, it's like I took this and I kept this part stationary and then I just flipped the rest around it, right, to get my new image. So then I just want to find the coordinates of those points. So K is now moved over here. So it is at positive 1, 1, 2, 3, 4, 5, 6, 1, 6. And L prime, let's see, is now over here. So it is at 1, 2, 1, 2, and then up 1, 2, 3, 4, 5, 6. So negative 2, let's see, negative 2, 6. And then M didn't change, right? So it is at negative 2 and positive 1. And then N is now over here, so it's at positive 1, 1, 1. Okay? All right, so that's rotation around a point. If we look at the next page, it says the rotations shown are clockwise rotations about the origin. Okay, so this is, these rotations are specifically around the origin. A 360-degree rotation is a complete revolution, so the original and its image are in the exact same location. So then this would map as x, y would be exactly the same. X prime, y prime would be the same thing if it was a 360-degree rotation. So in a 90-degree rotation around the origin, right, if I move this just 90 degrees, so again, think about your protractor. Okay, so if A is going this way, right, and it moves 90 degrees, it goes like this, okay, then that's your new prime, right? So then there are rules for these. So x, y moves to y, negative x. And if it's moving 180 degrees around the origin, then x, okay, becomes negative x, or the opposite, and y becomes the opposite, negative y. Okay, and then a 270-degree rotation goes from x, y. So y and x sort of switch places, kind of like over here. But x coordinate is now negative y, and the y coordinate is now x. All right, so these are just good rules. Highlight those or something, box them in, because you'll need to come back to these and use the rules when they're asking you to do a rotation around the origin. Okay, but again, these work for around the origin. So it's also, remember, these are all clockwise rotations, these bottom ones. But remember, a 90-degree clockwise is the same thing as a 270-degree rotation counterclockwise. So you can also use them for counterclockwise. You just have to know which one to use, okay? And a 270 rotation, if I go 270 this way, that's like going 90 degrees counterclockwise, okay? And then 180, if I go this way or I go this way, it doesn't matter. I'm still going the same direction. So 180 degree will be the same for either clockwise or counterclockwise. All right, so look at example 3. It says triangle DEF has vertices negative 4, 4, E negative 1, 2, and F negative 3, 1. Graph the figure and its image after a clockwise rotation of 90 degrees about the origin. Write an algebraic representation that explains the effect of the rotation. Determine the coordinates of the vertices for triangle D prime, E prime, F prime. So I want to start by graphing DEF, or triangle DEF. So D is negative 4, 4. So 1, 2, 3, 4, negative 4, 1, 2, 3, 4. It's right here. This is D. E is negative 1, 2, negative 1, 1, 2. It's right here. And then F is negative 3, 1. 1, 2, 3, and then F would be right here. Okay, so I can see in this triangle is starting right here. And then I'm moving it clockwise. So this direction, 90 degrees, about the point. This is my rotation that I'm moving. So I want to go here, 90 degrees. All right, so I'm going to use the rule that they've given me up here. So when I want to go 90 degrees clockwise, I'm using these bottom numbers down here. So I'm using this rule. It goes from xy to y, negative x. All right, so the x coordinate becomes the y coordinate. So y would be 4. And the y coordinate becomes the opposite of what the x coordinate was. So if this were xy, this is what it starts off, xy. So now it's supposed to be y, negative x. All right, so then x was negative 4, but now I'm doing the opposite of that, which would be positive 4. All right, and this starts off as negative 1, 2, but now y is going to be my x coordinate, so that would be the 2. And then the opposite of x would be a positive 1. All right, and here, this is my xy, this is xy, and I'm trying to change it to y, negative x. All right, so the y coordinate, it comes first, 1, and then the opposite of x would be the opposite of negative 3, which would be positive 3, 1, 3. All right, so if I graph these new points, 4, 4, so 1, 2, 3, 4, 1, 2, 3, 4, this is D prime. E is 2, 1, so over 2, up 1. And F prime would be 1, 1, 2, 3. F prime. And this is my triangle. Okay, so notice it's different than a reflection. Okay, it's in a reflection, these are not, a rotation, these are not symmetrical. If I put this paper, if I folded it together, these are not going to match up. F prime doesn't match up with something right here on the other side of this axis. All right, so they're not symmetrical. The whole thing is just sort of gone in a circle. We've shifted it around. Think of it as being on a string, and we just move it this way. All right, so if you wanted to look for that 90-degree rotation, what you could do is you can see from here, let's see if we drew a line like from here, D to the origin, and then we drew another line from the origin to D prime, then what you should see is that 90-degree rotation, right? And that should be the same for all of these. So like F, I drew a line from F to the origin, and then I drew another line from F prime to the origin. Okay, then that should be a 90-degree. All right, so then this whole thing has sort of rotated around that one point. All right, that's why these rules are really easy, because it's more difficult to just look at a graph and figure out where that image is going to end up. Here, if you use the rules, then you'll know you'll get the right coordinates. All right, so let's look at the last example, example 4. It says quadrilateral MNPQ has vertices M25, N64, P61, and Q21. Graph the figure and its image after a counterclockwise rotation of 90 degrees about the origin. Determine the coordinates of the vertices for a rectangle M prime, N prime, P prime, Q prime. All right, so in this last rotation, all right, we were going 90 degrees around the origin, and we were going clockwise. So we were going from here, this direction. In this problem, we're going counterclockwise. So we're going the opposite direction, still around the origin. So that tells me I can use the rules here at the top of my paper if it's around the origin, and I'm going 90 degrees. All right. All right, so when I'm going counterclockwise, 90 degrees, then I want to look, okay, remember these are for clockwise. So counterclockwise, I have to think of, okay, so what's counterclockwise 90 degrees? Well, it's the same thing as 270 clockwise. So the rule I need to use is negative yx for this one. So negative yx. All right, so if this is my xy, then negative y would be the opposite of 5. If this is x and this is y, then y comes first, but it's the opposite of that, so that would be negative 5. X comes second, and it doesn't change, so this is 2. Here in prime, y comes first, but it's the opposite, so negative 4, and then 6 doesn't change. And then 1, it's the opposite of y, so negative 1, and then x is the same. And then here, it's the opposite of y, but x doesn't change. Okay, so these are my new points around the origin. So let's see. Okay, So if I graph my first set of points over here, so 2, 5, 1, 2, 1, 2, 3, 4, 5. This is M. 6, 4, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. This is N. P is 6, 1. So 6, 1. That's P. And then Q is 2, 1. 1, 2, and then 1 right here. That's Q. Okay, so that gives me this figure. So I'm going 90 degrees this direction. This time I'm going this direction. But I can also think of that as going 270, so all the way up here, clockwise, right? So counterclockwise 90 is the same thing. Counterclockwise 90 is the same thing as doing all of this 270, okay? All right. So my new image is going to be negative 5, 2. So 1, 2, 3, 4, 5. 1, 2 is M prime. N prime is negative 4, 6. So 1, 2, 3, 4. And then 1, 2, 3, 4, 5, 6. Negative 1, 6 would be negative 1. 1, 2, 3, 4, 5, 6 is P prime. Q prime is negative 1, 2. Okay, so here we go. So this image has moved from here to here to here, all right? Or you can think of going backwards just 90 degrees. All right, so since rotated figures have the same shape and they have the same size as their pre-images, all right? So they're the same, the shape doesn't change, okay? And it's still the same amount, right? It's still 3 from here and 3 from here. Then they can be known as congruent figures. Their size doesn't change like in a dilation. The only time the size changes when you make it bigger or smaller. That's the dilation. The orientation, all right? So the direction of the figure, however, changed, right? It did change. So it will not be preserved because the figure turned, all right? So if the slope of MN right here is like positive, right here, you can see MN here was negative, right? So things are not going the same direction. It's not, orientation is not preserved. That's what that means. All right, so that's your rotation. Again, just be really careful to read things, right? So if you're using the center of rotation is your origin, use these rules here. If it's not the center of your rotation, then you're going to have to like think about that protractor that we used at the beginning. All right, at the beginning. Oh, where did my paper go? Right here. And then you just kind of have to find, you're gonna have to rotate it like in your head and then find the distance between the points. Okay, so those are rotations. I'll see you later.